Thank you. And hi, my name's Joe Andresen. I'm the technical product manager for HMI and embedded systems at Epic Games, and I'm going to talk a little bit about our HMI program. So to talk a little bit about what we're going to cover here in the webinar. I'm going to do a little overview of Unreal Engine for HMI, and then Minji is going to do a deep dive into the look development that he did for our demo and for our vehicle. And then Simone is going to give us an overview of the style switching feature that we have in our demo that was done in Blueprints. So a couple years ago, we started looking into what it would take to get Unreal Engine inside a vehicle. We had a feeling that as vehicles are becoming more and more digital with screens and touch, also adopting a lot of the hardware that is in mobile today, that HMIs would not be so different from developing a mobile game. And so we put together a team of engineers and artists and announced our HMI initiative. We have our first production HMI announced in GM's Hummer EV. We're very excited for that. And we have a dedicated HMI team of engineers and artists that are adding features and supporting HMIs as they get developed. We also have automotive focused engineers worldwide in China, in Germany, South Korea, and we also have scaling partners to help build out production interfaces in Sealy, Auto, and Vector form. So what we found when we were looking at HMI development was that games and HMIs have a lot of overlap in what they require and how they're developed. Like games, HMIs, require high visual fidelity in real time. When you're getting sensor data from the vehicle and you want to visualize that data, it needs to be in real time and it needs to be fluid. When you're interacting with the user interface in your vehicle, it can't be sluggish, it has to be performant. And so Unreal Engine, being a real-time game engine, is used to those kind of requirements. And so there's a list here. I won't go through everything here, but one of the unique things about Unreal Engine is that some of the features in Unreal Engine are industry hardened from Fortnite and from some of the other industries that contribute back to the engine feature set. And so if a feature of the engine is acquired from a game or from virtual production and it makes its way into the engine, HMI benefits from that. And the HMI work that we do also goes into the engine, and HMI doesn't use really a special part of the engine. It's mostly the same engine that everybody else uses. So being a core part of that mix of industries and being able to benefit from that is really cool. So this is our HMI demo, which we're going to kind of cover some of today. In order to test out, kind of our gut feeling and all of the features that we thought were good for HMI, we created a little HMI ourselves. We had a little fun with it. As you can see there, we have a Rocket League style with the Octane Rocket League car. It looks really great there. And we'll cover a little bit more of that later on. So one of the big things when working with Unreal for HMI that makes it different is this idea of design-driven development. In traditional HMI workflows, you usually have silos of designers and engineers, where designers will come up with a look and feel for a user interface, and they may work alongside concept people who will, define interaction or concepts for how that user interface will react to input, how it will function, how it will display information. And when they're done, they'll wrap that up in images, videos. In rare cases, you might get a small interactive demo where there's like an image and they press a button and then that animates another image. But usually that's packaged up and then kind of thrown over the fence to engineering, who, engineering has the hardware, they have test vehicles, and so they will code up the HMI and use the images and videos as reference and push that to the vehicle, and then the designers will have to go sit in the vehicle and drive it around, and a lot of things can happen. The engineers may have interpreted the designs incorrectly. Maybe they're using the wrong color for something and the designer has to correct them. Or maybe the designer made a button too small, and so they have to go back and make the button bigger. But the iteration time is a lot longer because the designer is not directly working on the product, so they have to go through engineering. And engineering gets bogged down with the designer requests to iterate and change the design. So what we propose with Unreal Engine is that there are no more silos. So because of the Unreal Editor's feature set with the ability to launch directly to device, the ability to package a project that can then be loaded on to a device, with the ability to have complete version control support within the editor so that a designer can not only import their textures and their 3D models directly into the editor, but they can then commit it to source control. All of these things and more allow artists and designers and concept people to directly work on the Unreal project that ends up in the production vehicle. And so what that gets you is you no longer have demos and hero screens and things that you're kind of throwing over the fence to engineering. You have prototypes that get iterated on. You throw away the prototypes that don't work, and you keep the prototypes that you like, and then you iterate and iterate and iterate until those become the final product. And that amount of iteration that you get, we're talking, a designer could sit in a vehicle and deploy their Unreal project directly to the screen and see in near real time the changes that they made. And so that iteration, the power of iteration there, can really give a designer a lot of power in improving their designs. And we haven't even talked about the engineers, because now the engineers are freed to work on more technical tasks. They're no longer working on designs and colors and effects where the designers can kind of take that work. And so then the engineers can help expose functionality via blueprints here to designers, so that the designers can kind of implement newer functionality into their designs. And then also they can help the designers with optimization and profiling to make sure that the designers aren't doing something that takes too much CPU or GPU, and helps the designers keep things performant. And so what we're going to do now is go over to Minji, who's going to talk about some of the look development that he did with our car for our demo.
Thanks, Joe. Hello, everyone. Welcome to this webinar. My name is Minji Wu, and I'm tech artist in the advanced project team of Epic Games, primarily focusing on the rock dev with cutting-edge real-time rendering technology. In the past few years, our team developed several tech demos which relate to the car industry. For example, McLaren 570S, the human race, and the speed of light. Before we start this project, François, the director of our team, asked us to deliver a demo whose visual fidelity is close to the PC rendering quality, but on HMI system. Meanwhile, we also set very high performance standard on the frame rate and the loading time. The demo runs 60 FPS with 2.5K native resolution. The loading time is less than 1 second. Thus, I will cover two topics: video quality, the performance and the package size optimization in the next few minutes. After analyzing and porting our previous demo on the certain hardwares, we believe that the clear code and the scene translucent shader are vital to a realistic car rendering on HMI system. Thanks for the help from our mobile rendering team, Jack Porter, Wang Mi, Liu Wei, Chris. They delivered these two PBR almost close to PC quality shader to us. Of course, our efficient mobile HDR rendering pipeline is also the key to achieve high quality rendering on HMI equipment. Now let's see the difference. The clear code shader on the car model shows more realistic metallic painter than the default lit one. The HDR rendering buffer keeps wide range of lighting. Thus, the rendering doesn't lose the precision of the lighting, especially for the highlight part. PBR material are another fundamental element for the realistic rendering on the HMI. We start with our automotive material pack. Time-wise, please check more detail in this link. There is misunderstanding on asset modeling. Most people think simplified gaming quality mesh is necessary for HMI production. But we found it was case by case, especially for car body panel. We suggest spending around 65% of your triangle budget on them, and our Datasmith plugin is a powerful tool for this task. I will explain more detail in the next pages. Now, let's see the final result on the screen. The HDR light lights high-dense triangle body panel with clear code shader. The accurate shape, lighting, and shading merge together. That's the reason why it's grab your eye and let you forget the negligible artifacts and the imperfect. Meanwhile, the scene translucent shader makes the tint windshield looks more realistic. It's not a thin transparent plastic sheet anymore. Let's change the color. The PBR material makes whatever the color we want, it always looks more realistic. Because I use the source copy tool, so the frame rate on HMI is much more smooth than the one you see it here. Performance is a big concern for HMI production. When I would like to keep a quality bar as it close to the PC render standard. Therefore, at the beginning of production, we made dozens of test maps to analyze the HMI's hardware and find the most optimal production solution. We test the CPU rendering ability, triangle pixel processing capability, loading time based on the different assets, and the category. Thus, we nailed down several performance guidelines for the production. I put them on this page. Total draw call is around 40 to 90 per screen based on the different hardware. We can easily merge these similar parts together and share material to reduce the draw call. Since different material were merged to one shared material, we need a mask to distinguish between red panther, chrome, gray panthers, different colors. Simplify material as much as we can. Reduce the shared instruction and the texture samples. Most of our material use less than 3 texture samples, and the body panel just use 1 texture. The reason why the body panel only use 1 texture is that we modeled the mesh with high triangle density. Hence, we don't need normal map texture anymore. We found the most hardware can handle 500,000 triangle on both performance and loading time side. Based on the previous discovery, we increased the triangle density so as to replace texture with verticolor. For instance, the mask textures. It not only reduced the GPU burden, but also speed the loading time. The general idea is that if it is for this smooth curved surface, we set them to high triangle density. Otherwise, we use low poly plus normal map solution. Texture cost is the most heavy part for the data loading time. For this texture which used on the 3D assets, we first tested the MIPMAP tools to nail down the purple size. Then we turn off the MIPMAP option case by case. Meanwhile, we set a rule: no texture larger than 1K can be used on the 3D assets. This is our custom-made MIPMAP tool to test the purple size. Now let's see how we do it in the editor. So the customer MIPMAP can change the color based on the distance. Then we apply it on the unlit material, and the assets use this material can easily to nail down which kind of size we would like to use. Then also based on the camera, we will turn off the MIPMAP. It will save the loading time, save the size, and help the loading time. That's all for the Rockdale part of this project. Thank you very much for your time. Hope you enjoyed the rest part. Now, I would like to hand the presentation over to Simon Lombardo. Thanks again.
Thank you, Minji, and hi everybody. My name is Simon Lombardo. I'm a senior tech artist and gameplay designer here at Epic Game. Today I wanted to show you a little bit of certain thing we did for that project and what kind of problem we run into and how we decided to solve it. So right at the start, when we start developing this application, we really wanted a way to be able to change things on the fly. For example, change the car color, which we can do, but also change the icon and change the font and change the background texture, all of that on the fly. And the way you will usually approach that would be to have different state or different style that you can load, which is either a complete different widget or different materials or things like that, different level. But we wanted to do that in a more flexible way. So the way we approach that is that we approach it kind of as a DLC system, which the main app will have a list of data, and based on the external app that you load, this one will be replaced. So you can see now if I swap between the both without restarting the app, I can have like the font being changed, the background color, the icon here, the icon here, and even the car has been completely changed. And that change is instant. So I can come back here and see the main car. But we didn't want to do that in the manual work because we didn't want to have to start changing all this little icon and font manually and decide, okay, which one goes there and stuff like that. But we wanted also a way to do that later on. Let's say you ship your main app and then you want to ship the new style. The main app doesn't have, we didn't want the main app to have to know about that external package. So you never have to update the main app to give it a new style. We just wanted the main app to be able to know what to do with the package that arrived, no matter what the package was filled with. So we approached that, as I say, as a DLC method. And the way we did that is that we created a structure that contained everything we wanted to be able to change on the fly. So for example, the home texture are there, which are RGB packed. So you can see we'll swap between these two icons. And they are RGB packed for performance. So each state of the button is packed into a different channel. But we'll have also things like font or font size, color, background texture. And you can add many things, levels, blueprint, anything you want. So we build that structure. We set up that structure. And the idea was that the structure will be populated at runtime based on which package is loaded, if any. If not, then it will read from the main app. And then that structure is being used in a blueprint interface. And that blueprint interface will be used inside every asset we wanted to be able to change on the fly. So what that blueprint interface does is just sending that updated structure. So the idea is that we'll create that structure on the fly, we'll populate it, and then every asset, every object or widget or material that reads something from that structure get updated on the fly, no matter what that structure is being filled with. So the way that structure is being actually filled at runtime is that we base it on a file name convention. So we created an extra plugin or DLC, and inside there is a specific folder structure and naming convention. So the structure knows when the function is started to update the structure, it knows to go to look, okay, I look into my plugin, and then I know that my icon are in a folder called icon. And then each of those have a specific name that basically tell, okay, the nav home will be the home icon, that the volume icon will be this. And then for the color, we'll use a material param collection that contain all the color with specific names. And again, it's the same thing for the font. We have a folder called font, and it's going to read from that. And then what it does is that that structure gets updated, the blueprint interface send that to the main app, and then everything gets populated, which is then instantly, and everything gets loaded only what you need. You don't load multiple things. So in that case, you see I'll click, and then he knows, okay, that's the home icon. I'll go there, fill it up, update the structure and send that to everybody that needs that structure. What is great about that is that you can then ship your main app, as I say, and then ship DLC package 6 months later. And without having to manually go to replace every texture, the only thing you have to do is just create that folder with assets. So that's great, for example, because I duplicated that folder as a new one. I call it WB for webinar. And inside the icon, I just replace a certain of the icon. So you can see I replace this with home icon and all of that. I change the color background to be green. And then in my material param collection, I choose kind of a green color and thing. So now I know that instead of calling the RL content, I just need to call the WB content. And I can do that really easily because we basically built the function to do that. So if I will go to my style, the icon are on the side there because they basically slide in. That's an extra polishing just that we did. You can see that you see the slide out and in, so they're there. But on that button, I'm calling that function and I'm telling which style I want to call. So for right now, I'm calling RL, so he knows how to look into the RL folder here. But let's switch that to WB. That's an enum that I created, but you can add as many as you want to it. So I'll compile that and play. So now instead of going to look into the icon folder inside RL, it will look into the WB. So if I click that and I'll load the Rocket League and I click, and you can see that the icon and the new one from the WB, I didn't have to do any manual work for that. The only thing I had to do is basically populate my folder with my icon with the right name. I didn't have to place them manually and this kind of thing. So I can switch back. Now, the other extra good thing about that is that you can have more than one DLC and ship more than one style and this kind of thing. So, for example, let's make it load 3 different styles. So I'll go this one back to Rocket League, and I'll create a new button. Place it there. Let's make it a bit bigger. Let's add a little text. Okay. And that text will be something like WB style. So now we'll make that button call that same function. Here it has a lot of different options. In addition to that function to call to update the structure, it has things like change the picture inside, make the little animation, remove the black arrow and things. But in that case, it will be much more simple. So if I go into it, I will show you how to do that. So I'll get my button, and let's say on release, the only function I have to call is change style. Click that, connect the execution pin, and here you can see I have the style listed as my enum, but you could use basically a string in there. And the other problem we run into is like, okay, but what if we don't know the name of the folder when we ship? Because 6 months later, we couldn't predict what the style will be named or what kind of style we're going to add. So we created another function that's called list DLC. And what that function does is that it looks in the package where that app is installed and look if any compatible DLC are actually located there, and then we'll list them as string. So you could get from that one and then use it in the same function. And what that function does is pretty simple. So if you go inside, there is that swap button, which is the style and the design here, changing the icon. So this part is not used on every time. But what it does after is that it converts that enum name to a string, which is why you can use the string too as well directly. And based on that, it will look on the drive to see if it's a DLC and start getting all the font that you need, and then update the structure. Get all the icon, update the structure, get all the color, update the structure, play a little bit of animation. That's again polish, and then basically get all the actors that use that blueprint interface and tell them, hey, here is the new structure with the new data. So do your job and replace all of that with the new one. So if I were not to go back, to my event graph, or delete that, I don't need, I will use the WB plugin. So that folder instead. And the main button will use the Rocket League. Just keep in mind that because this one doesn't have the polishing and the animation in there, the black arrow will not be removed. But if I were to press play now and go back here and click on that button, I switch automatically to that new style. It basically went to that folder, populated the structure, sent that updated structure to every blueprint widget or actor that used that, and then change them on the fly. So now if I click to the white one, I can also still load the Rocket League. So I can switch to every style and add style as much as I want. And as I say, you can still update it, like for example, over the air and send that DLC that contain only the asset you need. And in memory, you only load what you're using. So these are not material swaps. They're not, it's just an updated structure, and the blueprint and the widget and all the actor inside this use that blueprint interface to know what data they need to read and what data they need to load. And then, for example, if I were to go to the WB, as I say, we use a material param collection. So let's say we want to change the orange in here to a different color. I'll go to where my material param collection is, and then go to volume bar 2, which is this orange color, and I'll say, okay, I want a pink color now. I click that, go back to the WB style, and now I have a pink color in here. And all of that is basically much easier in a way of you don't have to do that much manual work, but also you don't have to predict the name of the future DLC. You don't have to predict, like the name of the texture, as long as you follow that file name convention that is set up in the function. And this can be changed, obviously, based on your internal file name convention, this kind of thing. It will know what to load and it will know what to do with it. So that's like the way we approach the style switching, and the way we made it flexible for us to don't have to manually go in there and create new style and all of that. Basically get a new plugin folder, have the correct number of icon, and if you don't, it will rely on the original one, and then it will just load that. So yeah, if you have any question, just let us know. Thank you.